So let's begin our conversation about systems of equations. We will first look at systems of linear equations, and we will look at two familiar concepts, the concept of substitution and the concept of elimination. So first off, what is a system? A system of equations is any set of equations that is to be considered together. And a system has a solution if there is a value or values for the variables that when we substitute them in will make the equations true statements. So in example 1, here we have an ordered pair 6, 7. Whenever we take 6, 7 and input them into the equations, will that make them true or not? And it has to make both of them true for us to have a solution to the system. So 6, 7, well, which one's which? Is 6 x or y? And typically, we make sure that they're in alphabetical order. So x, comma, y. So if x equals 6 and y equals 7, let's try this into our first equation. 3x minus 2y equals 4 would become 3 times 6 minus 2 times 7 equals 4. And 3 times 6 is 18. Minus 14 equals 4. That's true. But it's not enough for one of the equations to be true. Both of them would have to be true. So let's look at the second equation. Negative 4x plus y equals negative 3. So negative 4 times our x value plus our y value equals negative 3. That would be negative 24 plus 7 equals negative 3. That's false. So it is not a solution. So let's look at a system of equations with 3 variables. So this would mean that x would equal 3, y would equal negative 1, and z would equal 6. So let's try our first equation. X plus 2y minus 3z equals negative 17. We have 3 plus 2 times negative 1 minus 3 times 6 equals negative 17. This would be 3 minus 2 minus 18 equals negative 17, which is negative 17 equals negative 17. That's true. Let's try our next equation. 3x minus y plus z equals 16. So 3 times 3 minus negative 1 plus 6 equals 16 would be 9 plus 1 plus 6 equals 16. That's 16 equals 16. That's true. Let's try our third equation. Negative 2x plus y plus 5z equals 23 would become negative 2 times 3 plus negative 1 plus 5 times 6 equals 23. So we have negative 6 minus 1 plus 30 equals 23. So that means 23 would equal 23, which is true. So our ordered triple, 3, negative 1, 6, is a solution to each one of the equations. So therefore, it is a solution of the system. So 3, negative 1, 6 is a solution. Now, what we don't know at this point is, are there other solutions? Maybe, maybe not. Now, we will be talking in this section about linear equations. And linear equations are, like what we saw on the previous page, just number times variable plus number times variable all the way until we get to the right-hand side. So notice, what is linear? Something like 2x plus 3y minus 5z equals 6. What's not linear? 2x squared plus 3y equals 7. Those types of equations are not linear. The exponents have to be 1 on our variables. So let's talk about solving by substitution. How do we solve a system of equations by using substitution? Well, in our equations, we're going to take and solve for one of the variables. And then we're going to take that result and substitute it into the other equations. This is where the name of the method comes from. We're substituting one value of the variable into the other equation or equations. And then this should get us down to less variables. We would repeat this process until we get down to one variable, and then once we get to that one variable, we would have a single equation with a single variable, and therefore we could solve it, and then we just go and back substitute. We substitute that result back into the other equations to find the other variables' values. So here we have a system of equations in example 3 where we can solve for one of the variables and substitute it into the other. So make note, I'm telling you how to solve it. So let's take the second equation, negative x plus y equals negative 9, and we can solve this for one of the variables. Doesn't matter which one. We could have easily done the first equation also, but this is just easier because it's easier to solve for our variable, y. So we have x minus 9 is y. So now let's look at our other equation. We have 2x plus 3y equals 8. And we're going to take this this value for y, we know y equals x minus 9, and we're going to substitute that in for y in the other equation. So this yields for us 2x plus 3 times x minus 9 equals 8. Notice we are down to a single equation with a single variable. So 2x plus 3x minus, and now we're going to distribute. And so we have 5x minus 27 equals 8. So this means that 5x would equal 35, and so x would equal 7. Now let's back substitute. We know that y equals x minus 9, but we just found out what x is. X is 7. So y equals negative 2. So the solution is 7, negative 2.